comes to automotive designs, functional safety, footprint size, and minimizing your bill of materials are design concerns that absolutely need to be addressed. You definitely want to make sure that your applications are adhering to ISO 26262. You certainly want to try to get that design of yours as small as you can, and then there is that BOM. Yeah. For all of these issues, problems with the supply chain can rear their ugly heads. But what if you had a solution that integrated the power supply, MCUs, and interfaces, and was developed keeping critical safety standards and certifications in mind, and kept your dependence on the supply chain to a minimum? Then you'd be talking about Infineon's PSoC 4 portfolio. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Marcelo Williams Silva from Infineon and I explore the multitude of benefits of Infineon's PSoC 4 microcontroller family. We examine how the high-precision analog blocks, high-voltage subsystem, and integrated communication interfaces of these solutions make a big difference when it comes to the footprint size, bill of materials, and functional safety of your next automotive design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Infineon. Hi, Marcelo. Thank you so much for joining me.
Thank you, Amelia. Always a pleasure.
All right, Marcelo. So first up, can you set the stage for us? Where does Infineon fit in the overall automotive market?
Infineon has been growing a lot and very quick in the previous years, especially after the acquisition of Cypress. We became a large supplier of microcontrollers. In the past, we used to be on the top 5, and now we're the second position, heading to the first position, which bring us to the conversation today, which we want to talk more about Infineon portfolio and why Infineon is being the fastest growing microcontroller producing on the space right now.
Fantastic. Now, I know from previous Chalk Talks that Infineon microcontrollers can be used in industrial and consumer designs in addition to automotive designs. So, where does this new PSoC fit into the overall portfolio?
Yeah, PSoC is being our low-end entry device today. We do have solutions that are just simple microcontrollers or application-specific microcontrollers like multi-touch or fingerprint for touchscreens, and also the PSoC high voltage, which has a wide voltage input, and it's being a killer on our portfolio in terms of a hero product. Talking about the roadmap, here you see that we have the full portfolio of microcontrollers for Infineon right now, that we start with the Auto PSoC as an entry line here, and then we have the Travail as our Cortex-M4 and M7, then the RX when you need the ACOD device. Also, we are introducing this year the TC4 devices, which I recommend you guys to check it out as well. And also by next year, we'll be launching the new families, but our main focus today is our entry line on Cortex-M0 Plus devices.
So, Marcelo, what does the roadmap look like for the PSoC in particular?
The PSoC itself, we are splitting the roadmap in 3 major families, I'll say. The PSoC 4 are the entry-level microcontrollers from 2.7 to 5.5 volts, which has all the Cortex-M0 capabilities, plus the analog front ends, which is a trademark of PSoC family. Then you move on the second column to the PSoC 4 HV, which means high voltage. Those microcontrollers goes up to 42 volts. You have the high voltage PA, precision analog, and the MS, which is mixed signal. Today we'll be talking about the precision analog ones, which are the ones coming out to the market, and it's been a big success for Infineon. And we, in the roadmap, very soon, we are having the PSoC UHV, the ultra high voltage, a microcontroller capable to do 150 volts.
Okay, so Marcelo, what kind of specific automotive applications is the PSoC a good fit for?
Yeah. The PSoC came in a very interesting time for Infineon, where our customers were asking us before the Cypress acquisition, like, oh, really do like RX for automotive and transportation applications, but is a big device, is a tri-core, it is a monster. We really need a tiny microcontroller that are strong enough to run all the transportation and automotive applications. And then it comes the PSoC after Cypress acquisition. We not just acquire them, but we are also creating and expanding the roadmap. So here you see a few of the applications for the PSoC, the ones that we are currently using, but you can expand much more than that.
Fantastic. Now, Marcelo, what are the key benefits or peripherals of the PSoC 4 family?
Yeah, the PSoC 4 family is not just a simple microcontroller, a Cortex M0 Plus. It has some specific features that is capable just on the PSoC family, which you have a large memory density aligned with performance. Also, you have lean drivers, CAN-FD. We do have a very nice analog front end area, which you can save some space in your bill of material, introducing the analog portion of the board inside the PSoC. Plus, also, we do support all the automotive and transportation software. You can put things like automotive drivers, or things that will be, I'll say, supported by the automotive industry inside the PSoC as well. So it makes a flexible device to address low-end applications in transportation and automotive.
Okay, so what kind of options do we have with the PSoC series?
Yeah, the portfolio for PSoC has been growing in the past decades. So we start with a very small device that just have 16K of flash, 2K of RAM, and then it can goes up to 384K of flash and 32K of RAM. Remind that there are Cortex M0 devices. They have a very low power capability, wide voltage inputs, and you have a lot of features that you can incorporate on those devices, making them very flexible and very cost competitive in your application.
Okay, so can we take a closer look at the PSoC Plus 4100S?
Sure. The PSoC 4100S Plus and the Max series are new families that we are launching for the PSoC 4 specifically. Here, we're separating the PSoC 4 family basically from the high voltage ones. The Plus series is a very interesting one because we could expand more the capabilities of a simple PSoC 4 plus a lot of analog portion for that. So you can see here on the purple square what we call it PAB, like programmable analog blocks, that you can configure those things as you wish, and then you can save some parts on your PCB like ADC, op amps, comparators. You can put capacitive sense, magnetic sense, and other kinds of application that PSoC is a leader on that.
Great. Now, Marcelo, can we dig in a little deeper into the high voltage elements here?
Yeah, now we are coming to the cool part. They said, okay, Marcelo, I know PSoC 4. It's cool that we have a good roadmap right now. What else the PSoC high voltage offering now? So here, what is quite nice is that we have a high voltage subsystem. So basically, the PSoC high voltage is a PSoC 4 with a plus of a high voltage subsystem. That includes a lean PHY, all the high voltage sense integrated dividers, and an LDO integrated on the device, which is 42 volts tolerant, which makes this device 42 volts capable. But what is very interesting to highlight from this point, Amelia, is the 3.3 volt output with 30 milliamps supply. What it means, you have a pin on this device that you are capable to power up your board, your sensor, up to 3.3 volts, 30 milliamps. So let's say that you have a board, you have 12 volts on this board or 28 volts if you're addressing a truck application. Then you are able to put a sensor in this board or any kind of other components and use the PSoC high voltage as a power supply for it.
Okay, so a huge design concern these days is the size of the footprint. Can the PSoC 4 HV help me here?
Yes, for sure. Another benefit of the PSoC high voltage is exactly that you are getting rid of other components in the board. So you're saving space. But a big elephant in the room today is the allocation part with the semiconductor market. That's sometimes been a challenge for engineering and procurement to find more components than the A and B ones on the board. And with PSoC high voltage, you are capable to integrate at least 3 components, which is the power supply, interfaces, and the microcontroller in just one device.
Fantastic. Now, can we also talk about the PSoC 4 HVPA? What kind of benefits are we looking at here?
Yeah, the HPPA, we have an integrated high precision analog device, which includes 2 Delta Sigma ATCs and the 4 hardware digital processing channels. What is nice for that, you can use this device connected straight to a battery or to some power elements that you want to monitor. So it is very, very interesting in this point of view because you have all the voltage dividers already done. You have the functional safety. So on the current family that we're launching now, we have ASIL-B. On the family that we are launching in the second semester with is the PA208, we have ASIL-C compliance already verified. And plus, you have all the integrated communication interfaces that we'll be talking later, like LIN5, CAN-FD, all the fault subsystem, everything in a very compact form factor, which is a key-of-N package.
So, can we also take a look at the details of the PSoC 4 high voltage PA 144K?
Sure. This device is the one that we are launching right now. If you take a look on the diagram block, you see that it's very close to a PSoC 4 with 2 major changes. Okay, on the bottom part of the diagram block here in this page, you can see that you have the high voltage subsystem, which are the 3 elements that we spoke a few slides ago. Plus, one thing that I want to highlight from this diagram block, if you take a look on the left side, on the code flash, data flash, and SRAM, we are adding a key feature on the PSoC high voltage, which is ECC, error code correction. So this was not available on the previous PSoC 4s, and because of customer demanding related to safety and to increase the robustness of the device, we added in all PSoC high voltage ECC.
Okay, so can we go into a bit more depth about the precision analog channel subsystem?
Sure. On the precision analog subsystem, majorly we're focusing high power measurements, which includes battery or current sensing, or even sometimes from motor control as well. So what we did, we incorporate the high precision analog peripheral inside the micro. So you can have extended current measurements up to 1500 amps. You have automatic gain control. So your microcontroller can act directly on that. You have on the voltage side, a measurement range up to 28 volts. So let's say that you have industrial equipment or a truck equipment that runs from 24 to 28 volts. You can do this measurement directly on the voltage side as well. On the temperature, we do have extended temperature from minus 40 to plus 125. And on the diagnostics, and I think this is another key part of the PSoC high voltage, is that we have the open shunt detector. So if you have any issue with your hardware, the microcontroller have enough intelligence to take decisions here. You have the voltage reference comparison for primary and secondary parts, and you have the channel cross checks. So this is like, in the past, I had an analog circuit that do this, but doesn't have intelligence. Here we are adding the benefits of the analog circuit plus the intelligence of the micro.
Okay, so you mentioned integrated communication interfaces earlier. Can you explain that a bit more?
Sure. We have integrated communication interfaces, which means the microcontroller is not an island. What we see in the applications today is, okay, we have the analog portion, we have the microcontroller just taking care of the application around the analog, but doesn't have communication to external world. So then you have to add a third part here, either another microcontroller or a bridge like a UART over CAN, UART over LIN. So our idea here with the PSoC high voltage was to incorporate also the communication portion. So you do have ISO-WART available. You have the CAN FD, which is the latest and greatest for CAN nowadays. And you have other serial communication blocks like I2C, SPI, or UART or LIN. On this case, you can use other sensors or other devices connected to the micro. So the micro will do much more than just taking care of the analog portion of the application.
So, functional safety is also a very important design consideration when it comes to these kind of designs. Can the PSoC 4 HVPA help me here as well?
That's a very important part, Amelia. So functional safety is being a core belief on all the Infineon ATV microcontrollers, and with PSoC high voltage will not be different. So then what we offer safety manuals and safety analysis report for all PSoC 4 HVPAs, plus all the user manuals, the safety manuals, so all documentation needed to be compliant with a functional safety in your application.
Okay, so what would an intelligent battery sensor application look like?
Yeah, that's a new use case. I would say that pops up a lot with the EV cars, but I would say on the past decade, especially because of airbags and all these safety systems on the car, it became also important on ICE, internal combustion engine cars. So we do have here a typical application, and also we have a reference design for this, which means you can have on top of your lead-acid battery, you can have a PCB or a small module where you have the device itself. Here you see on the gray area, the HVPA has everything that you need to work here as an intelligent battery system. So if you have a shortcut or something, the PSoC high voltage can take the ownership of the application here and act pretty quick. So we do have this system today in many cars already running as a prototype with the PA because it's a common application. So in case of a crash or anything that happens with the car, this system can open the battery to avoid fire or any major damage with the vehicle. You can see that besides the battery itself, everything is in one single device.
Okay, so Marcelo, you also said that this solution would be a good fit for a current sensor module, right?
Yep. People think like, oh, Marcelo, but you're talking about 12 volts only. In my electrical vehicle, I have a battery of 400, 800. So how it works? So remember that even though your EV runs on a high voltage batteries of 400, 800, 1200 or even 2000 volts battery, which call it the high voltage on many applications today, you still have a rail of 12 volts, especially for other sensors like braking, steering that are coming from combustion engine. As of today, they have not migrated fully to high voltage operations. So for this kind of applications, you see here in the diagram block that you can connect the micro on the 12 volts, okay, for the lead-acid battery or for the 12-volt rail, and you use it to monitoring your high-voltage battery packs using the shunt here. And then you can have this communication between the 12 volts range, which are supplying the voltage to the device, and the battery packs using the host ECU to monitoring both rails here, which is quite interesting for this type of applications.
Okay, so what about that precision analog channel subsystem? How do those blocks work together?
Yeah, for the first look, you say like, oh, Marcelo, looks very complicated, but in fact, it's very easy to use. What we did here is we decided to put the biggest request from all of our customers today in terms of the analog channel and analog digital processing channels and put this inside of a micro, but not just one capability, but multiple capabilities and make it more scalable. So then we decided to put this on this PACSS, we call it the peripheral here. And then you see that you have the precision analog input blocks. You have two channels that separate those precision analog inputs. And then you have on the bottom part an automatic gain control that control each one of those channels, plus the 4 digital processing channels. So with two readings from two different channels, you can have four different channels extracting exactly what you need in order to the micro works pretty quick.
So, Marcelo, what about the software support here?
Now we come to the fun part, right? Everyone likes PSoC. Now with the PSoC high voltage coming, it's a completely disrupted technology into the market with a 42-volt microcontroller. But everyone comes and say, cool, Marcelo, how I can get to work on those things? Where should I start? So our first tool here, it will be the Modus Toolbox. The Modus Toolbox is a unified tool for all Infineon microcontrollers, not just automotive and transportation, but also industrial and consumer. Here you see the link, but if you go to Infineon page, you see the logo on the right side, Modus Toolbox. That's where you can go. And then you can see here on the left side, on the code examples at the second line on purple, you do have not just the basic microcontroller software example, but you also do have code examples, for example, for AWS IoT, or also on the libraries down there, you see FreeRTOS. So OTA, so we do offer this all free of charge. Is a GCC compiler Eclipse based, and it's been a success that we are unifying all microcontrollers from Infineon to operate on this very powerful tool, which is Modus Toolbox.
Okay, so can we also take a look at the Automotive PSoC 4 and PSoC 4 HV solutions you talked about earlier, and particularly how these two solutions compare?
Yeah. One thing that people usually come to us and say, oh, Marcelo, it's cool that you do have Modus Toolbox, it's an open source GCC compiler, but I'm very conservative, or my company has been working already, partners like IAR, Green Hills, Kyle Arm, Tasking, Vector, how those things are compatible between the PSoC 4 and the PSoC high voltage. So here we created a tab that you can compare what is available today for PSoC 4 and what is available for PSoC high voltage. The plan is to have both columns exactly equal, so there will be no difference from PSoC 4 to PSoC 4 high voltage. But as of today, these are the tools that you see that are compatible. So you do have IAR supporting both sides. You do have Green Hills on some applications supporting both sides. Also, you do have the Infineon tools supporting both sides. But the plan is very soon, by the second semester, that both devices will be fully covered by our ecosystem.
Fantastic. Now, Marcelo, if my audience is ready to get started with this family of PSoCs, do you guys have any evaluation boards to help them out?
Yeah, we have not just one, two, but in fact, we have more than 10. So here I'm just highlighting the families of the kits and our bestsellers for them. Here in this page specifically, you're seeing the current PSoC 4 family evaluation boards. You see that the price of these boards are very cheap comparing to the competition. So it's very easy to get started. Even the ones that are not currently in stock are already coming to Mouser's stock very soon, and then will be available by the end of this month. Then you see that we have a flexibility from simple application boards to the ones targeting a specific application like the sensing or something like the touch or fingerprint exclusively.
So, what about the PSoC HV? Do you guys have a specific evaluation board for this one as well?
Yeah, for PSoC high voltage, since it is a very specific device, yes, we do have a specific board available. Here you see that on the left side is the evaluation board itself. So you have all the capabilities and the shunts available today is currently on stock. You can order anytime through Mouser. And on the right side is an application board. This one is not a kit yet. It will be, but you have all the design files available in Infineon.com. So then you can download and make it exactly this. Amelia, this is the IBS model. So you see that is very, very small, very tiny. And then you can run directly the application from the kit. So in this case, you have the source codes. But my point here is if you want to start working today, you can go straight with our evaluation board on the left side.
So you mentioned you have even more kits. Tell us about those.
Yeah, so that's the very interesting part here. Overall, it's a picture of Embedded World, which was in Germany in February, which we showed our new kits to the market. So we have all the kits that were available and kits that were prototyping at that time. The ones in green were prototyping here. That's why, because Infineon kits always red, right? But on the left side here, you can see that you have the part number of the new light kit that will be coming very soon to Mauser. This will be available by the second semester of this year. We do have already prototypes and we did all the validation, so it's now in production. And these kits will come with Arduino compatibility, a microelectronic bus, potentiometers to check the high voltage parts, capacitive touch, also the Infineon to go sensors. So it will be a very complete kit below $100 resale.
Fantastic. Now, tell me more about the automotive quality support for the PSoC HV. What does that look like?
Sure. People come to me and said, Marcelo, I like the PSoC high voltage. I like the capabilities of PSoC high voltage, but currently, I'm using PSoC because I already have Automotive library running on that. I'm able to port this library from current PSoC 4s to PSoC high voltage. Or they come and said, Marcelo, I'm new to PSoC high voltage. I really like it. I want to check what you have available in terms of ready-to-go software for specifically automotive applications. So on the automotive applications, we have the quality software support. So here on the block, you see that you run your application on the top, and we offer the middleware part. And also we do offer a software, which is very interesting and available for PSoC, which is called PDL. So Professional Device Library. And this one, you can run between the drivers itself, the middleware and the application, which turns out much easier to use the peripherals of PSoC on a real-time application like Automotive.
So can we talk a bit more about the middleware library here?
Sure. Zooming in, you can see that you still have the application layer on top, the IFX middleware. So IFX is Infineon, so it's a way that we call it Infineon internally in our slides especially. And then you do have the low-level drivers, what we mean the PDL. And here on the PDL, you see that you have all the device drivers to run on the microcontroller hardware. So it's kind of abstraction layer from the application to the microcontroller hardware. Why Infineon deliver it? It's because those are sample codes that have a high reliability in terms of how to access the hardware on the right timing and for the right purpose. It's not a production one. It's a library that you can use it as your reference. It's not a production one, but it solves, I would say, 90% of our problems or issues when you access the hardware part of the micro.
Okay, so can you explain a bit more about the tools and software support, especially within the HPPA and HVMS families?
Sure. On those three families, what we are offering today, it's pretty similar. Anyways, we like to put the three families in separate. So the ones that you are seeing on the left side, HPPA 144K, is the family that we are talking today. So you see that you have the low-level drivers, you have the Automotive PDL 1.0 Plus, you do have the safety library, all the ACUB functional safety documents, and is supported by the compilers from IAR. Also, we do offer the protocol stack from Vector or IHR. So what it means that you can use your own CAN or LAN protocol, but if you want one already validated in the market, you can purchase your library from those suppliers and incorporate with our devices as well. They are available and validated. And same with the HVPA, which is coming in the second semester, and HVMS, which is coming by the end of this year. So you see that the idea here is to show you a scope of what is available today if you have a specific application for the automotive market on PSoC high voltage.
So, Marcelo, what do you guys have in terms of documentation to help out my audience?
Yeah, one of the mantras for Infineon is not to be a bottleneck in terms of documentation, especially I would say in the past 5 years. So what we are doing, it's every single documentation available for RX, PSoC, and Travail is available in our webpage in a repository called MyICP. So it's Infineon collaboration platform. So here you can see that either you can search by the Infineon page. In the Infineon page, you have the My Infineon, which is separate from MyICP. And then inside the My Infineon page, you can find the MyICP. There is a banner on our main page for microcontrollers where you can click in, you sign an NDA, and you have full access to all RX, PSoC, or Travail documentation to start pretty quickly your new design.
Fantastic. Well, Marcelo, I think that's all I have time for today. Thank you so much for joining me.
Thank you very much, and looking forward for the next time.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Infineon. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.